Bismillahirrahmanirrahim. Dear students, today we start the derivation of radius of orbit of an hydrogen atom. I am talking about class 11 and this subject number 2 and this lecture number 10. So how we derive the radius of orbit of an atom. So the topic is derivation of radius of an orbit of an atom. We are talking about atomic structure. So in the previous lecture, we done the Rutherford's atomic model and also the very important points of Bohr's atomic model. Now, if we are talking about the derivation of radius of an orbit of an atom according to Bohr's atomic model. Bohr's atomic model. Actually, Bohr theory or Bohr model explains the planetary system, particle nature of an electron. Shells are going to be formed. These shells are round. Circular orbit we call them. So when we derive the radius of an orbit, so this Bohr model only explains the mono-electronic system. Mono-electronic system. Mono means one. And mostly we use the hydrogen atom which has atomic number 1 and atomic mass 1. This whole derivation is applicable for the mono-electronic system. We will only talk about the hydrogen atom. Helium positive 1 ion. Helium ions. Helium positive 1. Atomic number is 2. So when one electron is going to be removed. So helium positive 1. So the elements which have only one electron. Not a multi-electron system. Mono-electron system is going to be applied. So if you see the topic 2.2 and 2.21 derivation of radius of orbit of an atom, so we have here the examples for the hydrogen atom, helium positive 1, lithium positive 2, etc. So when we are writing here hydrogen atom which has one proton and it has one electron. Hydrogen atom has one proton and one electron which is a mono-electronic system, and we want to calculate the radius. This is the radius. This is the radius of an. We want to calculate distance of this radius. So this is the charge of electron and this is the mass of electron which is going to be revolved, and there are this is the proton charge on proton, atomic number is Z, and proton charge has a positive. Charge on proton is positive. E for charge. E for charge of proton and this E for charge of electron. So there the one proton, so it has a positive 1. It has a negative 1, so that's why E negative 1. M is the mass of the electron. So dear students, two forces are responsible. Two forces are responsible for here. The one force is called a force of attraction. Force of attraction, and there is other one is called a centrifugal force. Centrifugal force. So this centrifugal force is equal to mv square over r. mv square over r. This is called a centrifugal force where electrons are going to be moved. Centrifugal force. This is a centrifugal force where the electron is going to be revolved in the orbit. And other one force is called the force of attraction. Force of attraction between the electron and proton, positive and negative charges. This is called a force of attraction, which we called also Coulombic force. Force of attraction is also called a Coulombic force, and this force is equal to Z E square over 4 pi epsilon naught r square. This is called a we call force of attraction, or we call it a Coulombic force, force of attraction. Where Z is atomic number, proton number. E square means E is a charge on electron and E is a charge on proton. Two charges. E square. 4 is a constant, pi is a constant, and epsilon naught is also constant, which is called a permittivity constant. Epsilon naught is called a permittivity constant. This permittivity constant value is 8.84 into 10 to the power minus 12 coulombs square joules per joule per meter. This is called epsilon naught constant, which is called a permittivity constant, students. Now, when the electron is going to be moved around the nucleus, according to Bohr's atomic model, neither its emit energy nor its evolved energy. The energy of revolving electron is constant. Means these forces, this is a centrifugal force and this is a force of attraction. These forces are equal and balanced. So when these two forces are equal, electron can revolve. So according to Bohr's atomic model, the energy of revolving electron is constant. It's not going to change. So that is why these two forces should be equal with each other. That is why mv square over r should be equal to z e square over 4 pi epsilon naught r square. Suppose this is the equation number 1. These two forces are equal. These two forces are equal and balanced. Now students, if you see the equation number 2, so there is a r in here denominator and there is a r square here also. So it means that this r and this square is going to be cancelled. So equation number second will be mv square is equal to z e square over 4 pi epsilon naught r. This is the equation number 2. So this r and this square are going to be cancelled out. Only one r remains behind. So mv square is equal to z e square 4 pi epsilon naught r. So this is the equation number 2. And please remember this equation we have to use in the other derivation also. Actually, we want to calculate the value of r. If we want to calculate the value of r from here, so if we are going to cross multiply both, this one, if I divide by 1 and cross multiplication and then taking the value of r, then you have the value r will be is equal to, this is the r, z e square over 4 pi epsilon naught and v square should be the denominator side. This is the equation number 3. So dear students, if you are going to calculate from here, put 1 here, denominator side, then cross multiply, and if you take the value of r, which is a radius of orbit, that should be equal to z e square 4 pi epsilon naught times v square. And v square. So, thus we concluded that this question will be asked, small question for marks 1 or 2, maybe asked in the examination. Written here. We can calculate that radius of moving electron is inversely proportional to the square of the velocity. Like this. Radius of orbit is inversely proportional to the square of the velocity. It means that if radius is going to be increased, the square of the velocity is going to be decreased. Inversely proportional. Now, we are talking about the hydrogen atom. Hydrogen atom. When I am talking about hydrogen atom, atomic number is 1. Atomic number of hydrogen is 1. So I put 1 here. E, charge on electron and charge on proton, they are constant. These are the constant values. We done in the Milken's oil drop method for the calculation of charge. Same. Only sign is different. 4 is a constant. Pi is constant. Epsilon naught is a constant. Mass of electron is a constant. You have only v square. That is why if you are putting constant, then I should put equal sign. But if you are not going to put the constants, then I should proportionality sign. We don't do mathematics. So that is why radius of the orbit, here you must draw this one. You draw this. Radius of the orbit of an electron is, revolving electron is inversely proportional to the velocity of the square of the velocity of electron. So this is the proof from this equation. Now dear students, if you go back in the Bohr's atomic model, the last point, point number 4, angular momentum. The angular momentum of an orbit depends upon the quantum number. There are 4 quantum numbers we will discuss later. The first quantum number is the principal quantum number, which shows the electron is going to be revolve in the orbit. In the circular orbits, so this n is equal to 1, 2, 3, 4, 5. This is called a principal quantum number. So depends upon the principal quantum number, which is an integral multiple of h over 2 pi. That's why now I have to use the angular momentum. Angular momentum of electron is nvr is equal to nh over 2 pi. This is the angular momentum. Angular momentum of moving electron according to Bohr's atomic model after the point 3, after the equation number 3. So when we are writing the angular momentum here, you are seeing there is a v square. You are seeing a v square. So if you are going to cross multiply here, then n h will be equal to mv r 2 pi. If you are going to divide by 1 and cross multiply, you will get this one. So if I take the value of v, this is v. If I am going to take the value of v here, then v will be is equal to nh divided by m r 2 pi. If I take out the value of v from here, you will get this. This is from the angular momentum. But you are seeing there the v square here. V square. So you have the square on the both sides. Both sides you have to take a square for this one. So if I am going to square both sides, then v square, so v square is equal to n square h square divided by m square r square and 4 pi square. If you see your book, you can get this one. V square will be equal to n square h square 4 pi square m square and r square. Now students, if you put this value v square, this v square value, if you put this v square value in the equation number 3rd, this equation number 3rd, so we will get this. Dear students, already I am telling you that because I am writing on the board, you should write in your copy, because now I am going to comment this. These points you have to understand are very clear before this. You have to follow this one. So that's why I am going to omit this. Now, if I am going to write equation number 3rd, R is equal to Z E square divided by 4 pi epsilon naught m. This is, now here is a v square. So if I am going to put the v square here, then v square is equal to n square h square divided by m square r square 4 pi square, like this. This is the equation number 4. This equation number 4, just I put the value of v square. If you see v square value here, this is a v square value I put here. So this should be shift here. This n square, r square, 4 pi square should be numerator if you see your book. Yes. So equation number 5 I can write r is equal to z e square m square r square 4 pi square divided by 4 pi epsilon naught and n square and h square. This is the equation number 5. This is equation number 5 now. Now students, there are some common. You have to cancel it. You can see here is a m square and here is a m. So m and this square will be cancelled out. This is the r and here is the r square. Square should be cancelled out. And if you see the pi here, this is a pi, and this square will be cancelled out. So z is there, no z is there, e square, no e square, epsilon naught, no epsilon naught, m, there is no m, 4, yes, 4 is also cancelled. H, okay, H is only. So that is why equation number 6 will be like this. This is now 1 over 1 is equal to z e square, only m, only r and pi. Like this. Other are cancelled. Other terms are going to be cancelled. Divided by, you have a epsilon naught, no m, n square and h square. This is the equation number 6. Like this. Now if you are going to cross multiply, so z e square m r pi is equal to epsilon naught n square h square, like this. But if you are going to take the value of r, this is the value of r. Here the value of r you can see. If I am going to take the value of r, this is the r value, is equal to epsilon naught, this is epsilon naught, n square, this is n square, h square, this is h square, divided by z e square m and pi. This is the equation number 7. So, dear students, if you see in your book, equation number 5, r is equal to epsilon naught. This is n square. This is n square. H square. This is h square. And z. This is z. Then e square. Yes, there is the e square. And m pi. This is the formula of r, radius of the orbit of revolving electron for the hydrogen atom. Already I told you the Bohr's atomic model is only applicable for the monoelectronic system. So hydrogen has only one electron in the first and last shell. So that is why this is the value for this. Now students, if you see this equation number 7, the equation number 7, r is equal to epsilon naught n square h square let t square m pi. So there are some constant values. So take out the constant values. Epsilon naught is constant? Yes. N is not a constant. N is the principal quantum number of shells. Okay, we know that we are talking about monoelectronic system practically. But in the calculation, by using calculation, you can calculate the radius of first orbit, second orbit, third orbit, for the hydrogen, for the helium, for the lithium ion, you can calculate. You can calculate for this one. So that's why n is a principal quantum number, which is 1, 2, 3, 4, 5, 6, and so forth. So it is not a constant. So n is not constant. H is a Planck's constant, yes. Its value is constant, divided by Z. Dear students, when I am talking about the hydrogen atom, when this calculation is for the hydrogen atom, then Z is an atomic number. So, atomic number of hydrogen is 1. Atomic number of the hydrogen is 1 for the hydrogen I am saying you. But if you use the lithium ion, then you put 3. Atomic number 3. If you are using beryllium, then atomic number is 4. If you use helium, positive 1 ion, then you have helium is a 2. So when you are going to calculate for other elements, then this Z is not a 1, not a constant, then you have to put. But if you are going for the hydrogen calculation, then you must, when you are going to write, then must write H. H atomic number is 1. So Z is 1. Atomic number of the hydrogen is 1. So this Z is a constant for the hydrogen already I explained. E. Charge on electron is a constant. Mass of electron is a constant. Pi is a constant. It means that you have only n square. I am talking about the hydrogen atom. Hydrogen atom. But if you write Z, so now this is for the all atoms. For the helium you have to put 2, for the lithium you have to put 3, for the beryllium ion you have to put 4. But if I am talking about the hydrogen, which is atomic number 1, so that is why only you have a n square, and I have it already here. So, dear students, these are all constants. So if you are going to turn the page, there is an example. In my book, the page is 37, you have to turn to 3 pages. Derivation of wave number. There is example 2.2. And he said that calculate the value for these constants. Calculate the value of constants. So the scientists give notation for the constants and not. If you put not here, if you put not here, okay, it's just like this one. A, or less. Small a, like this one. If you put not something, in some books, not is written here, if it's in some book, not is down. So A naught, this is for the constant, means epsilon naught, h square, e square, m and pi, these constants. This is called A naught, constant. So if you put all the values, I am going to say the values there, these are all constant, you done this. Epsilon naught, I told you 8.85, 4 10 to the power minus 12 coulombs square per joule per meter. This is a constant. Pi is a constant 3.14. Charge on electrons constant 1.62602 to 10 to the power minus 19 coulombs. H is a Planck's constant 6.626 10 to the power minus 34 joule second. Mass of the electron is constant 9.11 10 to the power minus 31 kilograms. For the hydrogen, n is equal to 1. So if you put these values, then you will get 5.29 into 10 raised to power minus 11 meters. This is the value of A naught, means all constants, these constants. These constants. Value of all constants. See the book, you have to calculate yourself at home calculation, make calculation, this answer for this. Now, meter, big unit. Meter is a very big unit. So for the radius of the electron, which is very small indeed, so we can't use the big unit for this. So we have to use the smaller units. So smaller units are here angstrom, nanometer, and picometers. सर मैं सर आ गया हूँ स्कूल, थैंक यू, आप आ जाए। मैं आ गया हूँ स्कूल, ठीक है, थैंक यू जी, थैंक यू सर। So the students, you can see this is a meter, so we have to convert here. So converting, I'm writing here 1 angstrom is equal to 10 raised to power minus 10 meters. Nanometer is 10 raised to power minus 9 meters. 1 picometer is equal to 10 raised to power minus 12 meters. So this is a converter. So in the book, this is in angstrom. This unit is in angstrom. So that is why you have to use an angstrom. So 5.29 into 10 raised to power minus 11 meters. Now I am going to use the angstrom, so I should convert this in the 10 raised to power 10. This is 10 power 11. So 10 power 11 less than 10 power 10. So I have to reverse this point. So I must write 0.529 10 raised to power minus 10 meters. Just I have reversed this point to make a 10 because 1 angstrom is equal to 10 raised to power minus 10 meters. So I make greater 10 power 10 means times greater. Make it 10 here minus. So I should reverse this point here to make it 10. Okay. Now, if I am going to write here point, because 1 angstrom is equal to 10 minus 10 meters, so I should write here 0.529 angstrom. So this is the radius, like this one. This is the radius 0.529 into 10 raised to power minus 10 meters or 0.529 angstrom is equal to n square. So dear students, we are talking about the hydrogen atom. So for the hydrogen atom, H is equal to 1, N is equal to 1. So that is why for the hydrogen, first orbit of the hydrogen is 0.529 angstrom. This is the answer. Because 1 is square 1, you will get 1. So this is the radius of the first orbit. If you see the diagram in the very first wrote that radius from the nucleus to first orbit for the hydrogen is this 0.529. This is the answer. So dear students, if you see for the this is the one for the second means you make n square. This n square will be 1/6 angstrom. For n square, it means that it is going to be increase here. So as you are going to move from first orbit to second orbit, the radius is going to be increased. So if you are going to calculate for third orbit, it's also going to be increased. So dear students, this is the radius of an orbit. So I am going to finish this lecture here, and in next lecture I will explain the derivation of energy of the orbit. So thank you very much for this.